Good afternoon. I want to thank everybody for joining this webinar. We had a little bit of technical difficulties there, but we should be good now. We had over 130 people register. The audience today includes customers pelleting poultry, hog, cattle, rabbit, and horse feed. Plus, we have some single ingredient customers also, such as DDGs, soybean hulls, and canola. Most of you guys or gals are pelleting 1/8 inch to 3/16 inch pellets with some pelleting 5/8 to 3/4 inch cubes. The material I will discuss today is not specific to any one industry, but is designed to cover the basics. What things do I need to do, what need to look for, when I don't have the pellet quality that I want. Many of you are doing everything correctly, and this will be a refresher than others. Maybe it'll spark something, you'll learn something new. As time allows, we may have some time for questions. Everyone will remain muted during the webinar. In order to send me questions, click on the red arrow to access the control panel. Go down to question and type your question. Some of you already found this out. So the agenda, I'm going to be covering basically 6 main areas. Formulation, which is ingredients, particle size, the importance of conditioning, and dye spec, and also cooling, and then inspect to get what you expect. So what is pelleting? Basically, we're taking ingredients or a single ingredient. Okay, sorry folks, I apologize about that. Practice this and all of a sudden now it's acting funny, the presentation. So pelleting is taking ingredients with various characteristics or single ingredients and add heat, moisture, and pressure and forming them into a pellet. So basically the 5 factors here that we're kind of control pellet durability. Pellet durability is basically formulation. So we kind of put a percentage on them, which, I mean, they can vary a little bit, but it, kind of makes you think here a little bit. So formulation roughly is 40% of what makes a durable pellet. Particle size is 20% roughly. Conditioning's another 20, and we got the dye spec, and then we have being 15, and cooling being 5%. So when you look at this, 60% happens before the conditioner. 80% happens even before the pellet mill. And I hear a lot that, hey, my pellet mill is a reason why I have bad pellets. So there's a lot more that goes into making a good pellet than the pellet member. Remember, all you can control at the pellet mill is the motor load amps and moisture addition. To simplify, a pellet mill is a big hunk of metal. We control how good our pellets are. What affects pellet quality and capacity? Basically, like I touched on before, is formulation and the ingredients, the amount that we put in of each ingredient and the different types affect pellets. Fat content plays a huge role in capacity and in pellet quality. Having too much or not enough can definitely give you headaches. Fines return is also a big deal. The amount of return fines and incoming mash can hurt quality because the fines have already been through a heat process. Large amounts of fines can be difficult to pellet and hurts quality. Sorry, folks, we're having a little bit of issues here, and I'm not sure why. So we're just going to have to struggle through it. I apologize, wasting your time. So common ingredients versus characteristics. How does ingredients like corn and soybean meal and salt and sugars, minerals, fat, fibers such as alfalfa and that, how do they affect particle size? how do they affect particle size here? Bulk density. There's a big difference between soybean hulls and corn. The bulk density of each. How does it compact? How do they? Some ingredients are just natural binders. Others are not. What happens when we add moisture and added temperature? Some things such as proteins accept moistures very well where fibers don't. Does these ingredients, a certain ingredients, does it help or hurt capacity and quality? So basically, it's typically a balancing act. Capacity versus quality. The higher the capacity, as capacity increases, pellet quality decreases. People always say they want the max, quality, the best quality, but with the best capacity. Sometimes you got to give up one to get the other. So that's one thing to keep in mind. What's the most important to you? When we're doing startups and it gets to a point where, you got to choose between the two sometimes. So, that's something you guys need to know so you know where to be. General speaking, pelletability is where both quality and capacity are optimal. Protein equals good pelleting. Quality and it's good for both quality and capacity. Fat is not good for quality, but great for capacity. Good up to about 1.5 to 2% and 3.5 total. Fiber's okay for quality, but it's bad. It's not real good for capacity because it's hard to absorb moistures and that kind of stuff. So I think I skipped a slide here. I'm going to shoot up here real quick. What affects pellet quality and capacity? This is kind of an important slide here. So basically, we were talking about ingredients, the amounts of different types. Fat plays a huge role. Fines returned. The amount of fines coming into the mash can hurt quality, but fines have already been through a heat process. Large amounts can be difficult to pellet and hurts quality. Then we go to particle distribution. Obviously, the size, if we get too big ones, that can hurt and cause more fines also. Conditioning, we need consistent incoming mash moisture. Too much incoming moisture affects how much moisture or steam you can add. New crop corn is generally wetter. So this time of year, we're getting a lot of new crop corn here, and we always have people call in and say the quality's down. They can't get the temperatures as hot. They're having some wet chokes. Well, that's because your incoming moisture's your starting point. You're going from maybe 12 or 13% moisture corn to maybe something 15 or 16. Your choke range is around 16 to 17% moisture. So if you're coming in at that, you're leaving very little, not very much room to add some heat to that mixture. Too dry of incoming material too is difficult, as you can only add so much in the conditioner. You might even have to add water in a mixer before the conditioner. We had some of those calls come in this summer where they had 9% moisture coming in, the mash moisture, and that makes it tough to try to pellet. So they had to add some water even in the mixer before you can come into the conditioner. Steam quality, you don't want water in your steam, and kind of want more of a drier steam. Temperature depends on the material you're pelleting. High grain formulas run higher temps. Basically as and the thing too is that normally as the temperature increases, your motor load amps go down, so you can run more capacity. So that they kind of go hand in hand. Higher fiber formulas have a harder time absorbing moisture, so temps run less. Retention time is also important. We need adequate time to mix the steam and moisture in with the mash material. We like to have 60 seconds to where we get a good mix in there, so it runs smoother through the die. You get a better pellet, you get better capacity that way. The die spec, basically the thickness of the die and hole size plays a huge role. We'll get in more of this here in a few minutes. Cooling, basically the idea here is remove moisture and heat added at the conditioner. So whatever we add at the conditioner, we want to take it out of the cooler. So we went through here, so I'm going to get us caught back up here. So now we're here with ingredients. The big thing here with the ingredients, when we look at this, is look at the correlation between percent of protein and pelletability. So as you can see, like soybean meal is very high in protein and has a very high pelletability, whereas you look at the items down here where it says low pelletability at the bottom of the screen, they are very high in fiber. Again, items high in fiber has a hard time absorbing moisture, and which is heat, and it's harder to get through the pellet mill. So basically, you get out of what a pellet, what you put into it. So kind of saying one of the sales managers has garbage material in, garbage out. It's not a magic box in there where it's magically going to fix everything in the middle. So you got to look into formulations and how we put them together, because again, this is around 40% of what makes a good pellet. So if we do a bad job there, then it's going to be hard. It's hard on the rest of the line way down. So consistent material. This is one thing we kind of we talk a lot about. You can have consistent pellets if you want consistent material. I had a customer once said they wanted a pellet moisture at 12 consistently, but they gave us stuff, moisture's incoming from 11 to 14. So inconsistently up and down, needless to say, the motor load amps went up and down to follow it. So it was very difficult to get you a consistent pellet when you have inconsistent material. So pellet quality versus particle size. Small uniform particles help quality. Large particles, as you can see here in a picture, can cause fractures. How do you get those large particles in here? You might be something as simple as you have a hole in a hammer mill screen, allowing bigger particles to come in here. But as you can see here, you can see that if you look at the pellets in here and you get a lot of fines, or if you see a lot of smaller pellets, instead of if they're normally 3/4 of an inch long, and you see these little 1/4 inch pellets coming there, you can look at them and you can maybe see a big particle in there. That's not good for pelletability. It's also not very good, when you talk about particle size versus steam penetration. In order to get the steam in the middle of it, the smaller the size, the easier it is to get it all the way through. If you have too big of a particle, you may have a hard time getting to the center, leaving it dry, which is your temperature is not going to be quite as high. It's going to be harder to get through the die, and it's going to cause those motor load amps to go up and down, so you're not going to run quite at the capacity either. Reasons for good conditioning, again, uniform moisture addition equals uniform pellet operation. They work hand in hand. If you're struggling to go, this is one of the areas to look at. Better physical pellet quality, less fines, less waste. Decrease consumption, basically if you're not having to run a bunch of extra fines and extra material in here, you're going to have these decreased consumption of electrical energy, optimize capacity, you're making more pellets, not as many fines. Then you increase the life of the dies and rolls. Like I said, that dry material doesn't help the dies and rolls at all. Conditioning factors, what we kind of talked about, particle size already, retention time in the conditioner. retention time in the conditioner. So, we want to give it plenty of time to get mixed in properly. The ability of the ingredients to absorb moisture. Again, fibers have a hard time absorbing moisture. So the longer we can get get them in the conditioner, it helps us out. Steam and liquid addition and, and quality. I got a call the other week and somebody said they're having a hard time, with running the pellet mill. It goes up and down, and they did water addition. They weren't even metering it in. You got to know how much you're adding. If you're not sure what you're adding, then, you get the results you get, unfortunately. Equipment, do we have the right size? Are we using the right conditioner RPM and design? When I say size, a conditioner is not one of those necessarily that you want, the old saying is if a 2-pound hammer does it, a 10-pound hammer will do it quicker. Well, in this case, you want to size a conditioner to where we have about a 50 to 60% fill rate. So if you get too big of one, you're not optimizing your conditioning. So you want to match the conditioner shaft speed and conditioner size. So high shaft speeds for like liquid addition, basically water and molasses. Typically speaking, we would use around 160 RPMs or faster when we're using liquids or molasses. On low shaft speeds, for steam only, we're using around 80 to 100 RPMs. The faster the conditioner RPM, the tougher it is to get retention time. So let's say you're doing cattle feed where you're doing molasses and you're also doing chicken feed, also in the same pellet mill. And you're using steam for both. And if you're at 80 RPM, instead of 80 RPM, maybe you're getting 60 seconds. But if you were at 160 RPM, you're only getting 30 seconds of retention time. So I did a lot of conditioner testing, and it's very hard on those high-speed shafts to get retention time. Retention time, as a whole has gone up. How can you do it? You can adjust pick angles, which I would suggest getting with your local sales reps on what's the best for your application. So one question here is, how do you determine conditioning retention time? The first one here is the amp load method. Basically, you stop the feeder. Basically, you get a stopwatch. So you stop the feeder, get the stopwatch until the pellet mill is close to idle amps. Idle amps are the amps when you have no feed. So when it gets kind of close to that, you click it off, and you roughly get it. The second way here is more accurate than the first. Basically, it's a whole corner or die method. You add it at the discharge of the feeder, collect at the pellet mill inspection door. You will get bell-shaped results. Basically, a conditioner is not a first in, first out vessel. So you may see some corn get there in 15 seconds and some corn get there a minute and a half later. It's not going to work out. Just because you put it in, it's not all going to come out at the same time. So that's what we kind of look at it with, more of like a bell-shaped curve. The third way is probably the most accurate, but the most work. Weigh conditioner contents at known tons per hour. Stop the feeder and conditioner. Example, 50 tons per hour. 1,750 pounds is collected from the conditioner. 100,000 pounds per hour equals 27.8 pounds per second. Basically leads, when you divide them, equals to 63 seconds. Again, that's the better way. The first way is the quickest and easiest way. If you're not doing it, something I would highly suggest. Understanding the dynamics. Oil and water don't mix. So if you got, it's hard to add water to an oily substance. Again, fibers do not easily absorb moistures. Low bulk density ingredients equals lower capacity. It's harder to feed it. It's harder to move it. So it just makes it tougher on capacity. Moisture is the conduit for temperature change, both for heating and cooling. basically hot air carries more moisture than cool air. So that's why having the hotter the air actually helps cooling. So when we're trying to pull the moisture out of the pellets at the cooler, hotter air carries more, so that's why hotter pellets actually. That was a hard one for me to kind of wrap my head around, but it makes a lot of sense once you look at the science and you get out in the field and see that, it actually makes a little more sense. Conditioning action items here. Check retention time and adjust picks when needed at least once a year. And then check paddle and pick wear twice a year. So one thing, we get a lot of people coming here and they're having problems with their conditioning. They're not getting good retention time, and they're having a hard time pelleting. It's hurting their capacity. One of the first things we ask is, how far is the pick to the shell of the conditioner? Ideally, you want to basically get your tip of your finger underneath there in between. Basically, you're looking at about 1/4 to 3/8 of an inch. If you got a gap that's over a 1/2 inch or to an inch, 1/2 inch to an inch away, you try to adjust them in. Some of them you can put washers in and push them out to the shell, or other times you just need to replace them. Because if you're running with that big of a gap there, it's just more or less a glorified feeder at that point. You're not getting a lot of mix rate. And then clean temperature probes. Basically, even if you got a flat temp probe, if you have adjusted down, if it's not flush with the shell, feed can get on top of it, you have an inaccurate temperature. Also, if you have a stick probe, you can get mash on it, and then it won't read properly either. So how do you know where you're at if it's not accurately reading it? So now we go to pellet cooling here. Pellet cooling, we said it controls 5% of the durability factors. I think pelleting can hurt more than can hurt you more. So you can have a great pellet coming out of the pellet mill. You did everything right, then you get to the cooling and do a bad job of cooling, then all of a sudden you have a bad pellet. So what's the goal here? The goal here is to take out you don't want hot pellets, because hot pellets will spoil. We're trying to remove the heat and moisture. They also leads to waste, and then it hurts the health of the bird and animals. Wet or moist pellets can also spoil, hurt feed conversions, diluting nutrients, and also increase trucking costs. So the integrators on the phone here, on the call, that feeding their own birds, they don't want to haul water. They don't want diluted nutrients. They want good stuff, and they don't want to have to haul extra water. So what are our goals of cooling? Basically, the temperature of the pellets at the discharge of the cooler our goal is to be within 10 degrees Fahrenheit or 6 degrees Celsius of ambient temperature. When I say ambient temperature, I mean the temperature at the cooler, not outside. So if it's by the cooler, the air we're sucking into the cooler to cool the pellets, if it's 80 degrees and it's 50 outside, we're wanting it within 10 degrees of 80. Moisture of pellets at the discharge of the cooler need to be within 0.5% of beginning mash moisture before the conditioner. So if we have a beginning mash moisture of 13, we need to be within 13.5. Now, if you want that to be 12, you're going to have your mash moisture down, lower to start with. We don't have a dryer. Unless you have a dryer in there, the cooler is not going to go below the starting mash temperature. And one of the big things here is retention time, and the cooler is key. Pellets basically sweat and need time to draw the moisture from the inside out of the center of the pellet. Too much air can dry the outside of the pellet, leaving moisture to be trapped inside. This can cause pellets to break apart and causing fines. So again, it takes retention time. If you're using a counterflow cooler, you want to try to get as much time in the higher bed depths to try to get that out of there. If you're, horizontal cooler, kind of the same deal. You can also, on a horizontal cooler, you can also slow down the top level if it's a double deck cooler. So the next thing here we're going to talk about is die specs basics. As effective die thickness increases, the throughput decreases. The thinner the die thickness, the throughput increases. So thicker the die, better the pellet. Thinner the die, better the capacity. Again, this is kind of go back to what we were talking about. What's important to you? Do you need capacity or do you need quality? What are you willing to give up? Sometimes you got to give one to get the other. Basically, when I say a thicker die, you're giving more retention time in the die, which improves pellet quality. The longer it can set in that die, even though it might be, seconds or less than a second, sometimes depending on the capacity, it's going to compact that pellet even better and make a harder, better pellet. Hole size affects capacity. There's a big difference between a 2 millimeter pellet and a 4 millimeter pellet. Capacity goes way down going, if you're used to doing around a 4 millimeter pellet going to a 2, I mean, it's even less than half. And then obviously cubes, you're talking about something that's a 5/8 or 3/4 and very fibrous, your capacity goes way down also. So dies and rolls, what to look for, inspect worn dies and rolls. So, dies tramp metal. Sometimes magnets won't get stainless steel stuff. Sometimes we have the magnets in place and nobody checks them either, and you get the tramp metal, and the tramp metal tears up stuff. Anytime we have tramp metal, it can crack a die. But one of the big things you see right away is it can also plug the holes. You lose capacity. Again, it can make dents and tear up stuff, so your quality goes down also. Abnormal wear, abnormal wear, you can kind of see in the picture here where it looks like the edges you weren't pellet, it wasn't pelleting on the edges, but the center it was. That could be a die spec problem. That could be a problem with a deflector or wiper not feeding in there. Every die and roll tells a story. And same thing with the roll. You can see the roll down here. You can see right now on the edges was doing all the work, and the center roll wasn't for whatever reason. So, obviously you'd want to see the match of the die and the rolls together, but this just kind of gives you an idea. Somebody sees that roll and customers are wondering why I'm not getting capacity. Well, you're not feeding the whole roll or the whole die. If you're not feeding the whole roll or die, then obviously it's going to hurt capacity. Might need, again, I would talk to your local sales reps. They can dig into your individual cases, but those are definitely something. Anytime you change out a die, obviously anything shiny on the clamping area is a red flag. So you guys definitely need to take a look at that also. Anytime dies and rolls come out, I would highly suggest you take a good hard look at it to see how we can improve. So this one here to me is probably one of the most important parts of the whole thing. We get people that call in and they say, hey, we're having problems with our pellets. What's wrong? I don't know. The customer says they're bad. Well, what's bad about them? Is it moisture? Well, do you check moisture? No. Or if you're getting wet pellets at the end too. So what's your beginning mash moisture? One of the main things here is we need to check incoming mash moisture before the conditioner. And this also helps you as an operator realize where you're at. If it's hard to make adjustments when you don't know where you're at. Check mash moisture and temperature before entering the die. If you're having a problem, maybe you're getting, with plugs or quality, make sure you're at, how much steam you really are adding or how much moisture you're adding, at the conditioner. The good way to do that is do it right before it gets in, into the pellet chamber. Check pellet temperature and moisture leaving the cooler. Again, we don't want wet pellets or hot pellets. Check fat content of pellets. Basically what I'm saying here is if you're getting a lot of pellets, let's say you're getting a lot of fines, and maybe you need to double check that you're really you have as much fat as what you think you are. Basically total fat, we like to try to stay under 3.5%. Maybe you have more than that in there. If you get too much fat, again, too much fat is bad for pellet quality. So maybe you're getting too much fat in there. And then check the, PDI, pellet durability index of the pellets out of the cooler. Make sure you are giving that good pellet. So if somebody questions, your pellet quality, you can go back and take your notes and say, hey, this is where we were at, and at least you have an idea. So at this point, I'm going to questions. Okay, so the first question here I have is how to quickly identify good or poor steam quality. If you have unexplained wet chokes, look to steam quality. 100% saturated steam is the goal, all vapor. So basically if you have boiled water in a pan and you see that white cloud, we're talking about the vapor before the white cloud there. Basically, you put your hand in there and it burns you. That's the kind of steam we're looking at. Condensation or wet steam, basically when we're saying condensation, we're talking about the white cloud, indicates poor steam quality. Then you have to look at your entire steam harness to look for causes, such as traps not working or condensation lines not open, insulation on steam pipes missing, etc. We also might do a webinar just on steam, as it has a tremendous effect on the pellet mill running smoother and consistently. This was kind of the first step here. If we're going to do more of these webinars, this was kind of the first step in here, to try to set us up for future webinars, hopefully. So the next one, do you have a PDI standard for poultry, shrimp, or cattle? Basically it's going to go, at the end of the day, it's going to go to what your customer wants, what your company standards are. I know if I'm selling a 50-pound bag of feed, you don't want to open that thing up and see 10 pounds of fines in it. So, I can say 90 plus PDI, but there might be some people that would say less. Again, that's going to have to be between the company and your customers. Another question we have here. For wood pellets, do you have any recommendations? Wood pellets, I always tell people when they want to pellet wood pellets, it's a very hard thing to pellet. The same mill, we might get 40 ton an hour of chicken feed. We were lucky to get 5 ton an hour of wood pellets. So, to really dig in, we'd have to have, as far as recommendations, you'd have to be a little more specific with me as far as what you're talking about, quality or capacity or what here. Another question here, what is the most common cause of bad quality of pellets? Again, look at the ingredients. Too much fat will, it's great for capacity, and that's one of the things, hey, capacity is great, but quality is bad. Well, look at the ingredients. Maybe you got a little too much fat in there causing it. basically it's everything I mentioned. Moisture also plays a big part of that. Again, cooling, good conditioning, and good cooling. If you're doing a good job of mixing, getting 60 plus seconds of retention time, that's where I would go to. Go to that conditioner first, and then make sure you're getting all the moisture and heat back out that you're putting in at the cooler. Those are the first two areas I would look at. So is steam recommended for pellet mills or wood pellets? I mean, wood pellets. Usually you're going to use water addition in there, and that's a big thing in wood pellets. I know sometimes they even do ripening bins and that to try to get the moisture. Again, you're talking about fibrous material, and it's hard to get moisture in fibrous material. So if you're not doing, it can be used, but not usually. This is one of the ones where I would probably get with. We got a biomass rep named Tim Gilbert. He'd be a good person to bounce ideas off of. More than happy to get you his information if you want to send me an email afterwards. Okay, I think that's going to finish it for today. I really appreciate you guys all sticking with me through our technical difficulties. If you have any questions outside of this or something pops up down the line, feel free to get a hold of reps and they'll be more than happy. They can reach out to us or anybody in the office to help them with any questions. Thank you.